Alright, yo, vectors. I've actually seen some vectors in geometry textbooks as well. And the reason I think that they're in some geometry textbooks is because really this is just right triangles. This is absolutely additional applications of trig. So if you kind of lean on that right triangle situation as you're thinking through this, I think it'll really help you. So vectors give you magnitude and direction, like vector from Despicable Me. Right? So a vector is direction and magnitude. Here, P and Q, like dealing with P and Q is the absolute most missed problem on every test. And it's just kind of finding that length there that we're going to have to work with. Okay. Let's get back to the original slide. So P is our initial point. Q is the terminal point. We know that because that's where the little arrow is. And the double bars in front of around PQ there just tells you you're finding the magnitude. Magnitude is the same as the length here. So we are going to, when we can, center things at the origin. Because when we center at the origin, when our initial point is the origin, our vector is just the same as that terminal point. So that terminal point here would be over A and up B, and the vector would just be the vector A, just like that point is A. I don't know what the little, like, the vector notation that we use in here has like the little pointy guys around it. That's how you know it's a vector instead of a point. I don't know what those are called. They're in pointy parentheses. I forget what Mr. Schaefer called them last year. Okay. So we call, these are components. This guy is the horizontal component. Horizontal component. And this guy, what do you think that guy is? The vertical component. Nice. So horizontal component, vertical component. How many from your start, how many are you going over? How many are you going up? It's going to be negative if it's left. It's going to be negative if it's down. Okay? Great. Let's put a couple of these on the coordinate plane. Write and draw the vector whose initial point is at the origin and the terminal point is given. So if we're going to point 4, 3, we're starting at the origin with our terminal point. We're going over 4, up 3 is where our terminal point is. So initial point at the origin, terminal point at 4, 3. To draw the vector, we draw the line segment and put an arrow on it. I know, like that's too much for one big line, right? So the way we write that vector is just we went over 4. The horizontal component is 4. The vertical component is 3. For negative 3 halves, or negative 1.5. Again, we're going to have our initial point at the origin. Left 3, down 1.5. Up. Make sure you draw that arrow. That shows us where the terminal point is. And then we're going, our horizontal component is negative 3. Our vertical component is negative 3 halves. So when you're starting at the origin, everything is very nice. Okay, when you start at 0, 0. It's when our initial point is off the origin that we have to be a little careful, and there's a couple little equations that you have to be able to deal with. The first is to get component form from your initial point and terminal point if they're not on the origin. And that situation is like this guy out here. And this is what I was saying. This is always the most missed problem, and it makes me want to put a hole through your quiz. Because it's easy, and you can do it, you just forget the steps. So what you have to do is you have to find, like you have to do a little bit of subtraction. And the subtraction here is of your points. So this is points to component form. And all you have to do to find this is make sure you do terminal minus initial. So it's like distance formula. Really, you're kind of against distance formula. So this right here, your vector is just terminal minus initial for your x's, terminal minus initial for your y. For your x's and for your y. The length you find by actually doing the distance formula, and that gives you the magnitude. So if I ask for the magnitude, all I'm asking for is the length. And you can make a right triangle and do Pythagorean theorem, or you can use this. This is distance formula, which of course is Pythagorean theorem's baby. Distance formula is just a different way to write Pythagorean theorem. Take a second, look at your equation sheet, see what you have. You have magnitude, you don't have 2 points to component form. So good to know what you don't have. At magnitude, you don't have the 2 points to. So let's practice with 2 points to component form. A lot. Like that's what this whole next page is. So for example 2, we're finding the vector and the magnitude. So I'm going to start just by drawing it. Our vector, each of these vectors starts at P and ends at Q. So P is the point 2, 1, so over 2, up 1. Q is the point 5, 5. There's my vector. I drew it, and let's go ahead and find it. So to find this vector using these points, what you do, you can kind of think of it as x1, y1, if you would like, x2, y2. You're going to subtract your x's, but order matters. 5 minus 2. And subtract your y's. 5 minus 1. Again, you're doing terminal minus initial x's, terminal minus initial for y. And that goes from 2 points to your vector. That's an equation that will always work. And so this is the vector 3, 4. There's your vector. If you look at your graph, if we started our initial point here, how many are we going over? 1, 2, 3. How many are we going up? Hopefully 4. 4. Okay, that's not an accident. That's what you're doing when you find that vector. If it's not at the origin, you're really, how many are you going right or left? How many are you going up or down? That's why it's called the horizontal component and vertical component. Super easy, but in my experience, super easy to forget as well. Okay, magnitude. Magnitude is the length. If those two sides are 3 and 4, how long is that, our little guy? There, 5. So, let's call this B. It is a 3, 4, 5 right triangle. The magnitude is 5. You can do square root of the squares there. If you're like, I like to always check it. There was one time when I thought it was a 3, 4, 5, and then it wasn't. That's fine. 9 plus 16 is 25. Okay so far? Okay. More vectors. So I'm going to start at negative 4, 1. Negative 4, 1. And I'm going to end at 1, negative 3. I know these little graphs aren't the nicest to count on, and I didn't really do that on purpose, but I do think it's good practice to do this subtraction. So to find our vector, we're going to do our subtract our x's, 1 minus negative 4. Subtract our y's, negative 3 minus 1. You won't always be given a graph. 1 minus negative 4 is positive 5. Negative 3 minus 1 is negative 4. There's your vector. This one is not a special right triangle, so we do have to go through the work of finding the hypotenuse here, or just using our distance formula. If you want to double check that, absolutely make your right triangle and double check. Make sure you're going over 5, down 4. That's the nice thing about vectors, they do give you that direction. And you don't have to be at kind of at the center, at the origin, like we have been on the Alright. Magnitude, square root of the squared. And you're going to use these little double bars to denote magnitude. Remember, when you square a negative, it becomes positive. Not saying that I saw that on any color test, just a reminder. 25 plus 16 is 41. Alright, try the last one.